static of information. So that is not true. What you have is you do have some anonymous monolithic, but you have partially dynamic, you have news-oriented, which is more dynamic. Authenticated users have a largely dynamic page, and an admin user would have a fully dynamic page. So you have many levels of caching that could be your target. So caching in D8 would be the art of trying to never compute or create anything more often than needed. And you can cache in many different places, which I'm going to show you real quick. But you can cache an entire web page, which is the most commonly thought of part. You can cache a portion of a web page, like a block, or you can just cache the data that is being used to create your block that's going inside that page. And actually caching data turns out to be very important. So all the items above can be cached. So try to get a strategy together. You know, it seems unplannable at the beginning, but like I told you, if you set some objectives for yourself, you'll be able to do it. Okay, there is actually a beautiful specification from the W3C on caching indirectly, but it's called the Edge architecture specification. So the edge of your website is like the last place where you're creating stuff before it goes out to let's say, the internet, the network, and people's browsers. That's your edge. Beyond your edge, there are surrogates or intermediaries, also known as reverse proxies or proxies. This is other computers between your website and the browser that the user is using, where things can be cached. So your first, from your web server, your first caching place is usually Varnish, which is an edge cache server. Then there'll be multiple proxies on the way, like for example at universities or governments or big corporations. They may be caching internet stuff in their own cache servers before they go to you in your browser. And if you haven't seen that situation, you will see it sooner or later, where you're going to make changes on the website and the customer is going to say, I don't see it. And you're going to say, I know it was cached and invalidated and recached. You have to see it, and then you find out they're caching it, you know, someplace else in between. So, and a bunch of surrogates out there that are doing what the web server wants. The web server is the origin. And so anyway, a bunch of surrogates out there are commonly called a content delivery network or a CDN. And what happens is the origin sends out surrogate control headers to all the surrogates. And the surrogates send back their capabilities. They advertise their capabilities in the request back to the origin. So, like, we're not going to talk about the technicalities of these, but it's good to know that they exist, and this is how you visualize it. And all of this is happening in your HTTP headers. So if you haven't spent much time yet looking at your headers for things like expires and cache control and e-tag and cookie and set cookie, when you finally get into the granularity of caching, you have to look at all of this. So this is a really quick overview of all your caching junctures in your typical enterprise website setup. You could be caching inside MySQL, where some of your queries can be cached, so that the data that they pull is getting cached by MySQL itself, so that when the same query is made over and over again, it doesn't have to go get it all over again. Then, commonly also, between PHP and MySQL, there are two kinds of other object caches called Redis or Memcache, and they typically will take a response from MySQL and hold it here in cache also, so that when PHP asks for information from MySQL, it looks first to see if it's been picked up before by Redis or Memcache. So you can have MySQL caching queries that PHP is commonly making to MySQL get cached by Redis or Memcache. PHP, the entire output the entire byte output of a PHP request can get cached into PHP's APC cache, so you have that cache going on. Now you finally make it into Drupal. And Drupal has two built-in modules, a dynamic page cache, I think, and an internal page cache they call it. We'll get to them. Then there's the BigPipe concept, which we'll also get to, and then there's the performance settings on the performance page. So now you've got basically your web page is finished. Edge side cache is when you include more dynamic information in your now already technically finished static web page. Edge side cache is done at the cache server, and server side includes is when your web server will pull in additional information into blocks on what is, like I said, already a finished web page. So now they'll leave the server, path across the internet, get into your network wherever you are, finally hit your browser. You have the information. Other things that could be going on, and so you can see that the surrogate control headers are flowing down and the surrogate capability headers are flowing up. Once you're at the browser space, a couple of things are still happening that are related to caching. Images, scripts, and other files are commonly coming from CDNs like Akamai. And then there's usually a master CDN location, and all of these other CDN locations around the world are called POPs, or points of presence. And a CDN that has numerous points of presence, like Fastly or Cloudflare, are saying to you, I can literally serve a page faster in Europe because I've got a point of presence that already has all your cached matter here, waiting to go to Europe in 0.25 seconds, rather than come from the United States in 0.45 seconds. So that is what a CDN is accomplishing for you all over the world. The master CDN, after it gets your stuff the first time, sends it out to all of its points of presence and maintains control. A CDN like Fastly says, the moment you invalidate something, and invalidating something in caching is when you say it's expired, it's stale, I want to give you a fresh one. Fastly says the moment you invalidate something in like 0.15 seconds, every pop in the world is current. That's how fast they are. They're basically saying to you, literally, if you invalidate something in the cache, it will be refreshed around the world in under a second, and everyone will have it. So typically, this is coming from your file system and not from your web server, the dynamic pages. But like I said, your JS files, your images, documents. And then often you actually can have an interface here where you can go in and literally say, I would like to invalidate this JS file, hit OK. And it'll do that, pull a new one, and immediately distribute it around the world. So another form of, I think of it as caching, it is technically not. But once you're in the browser, you can fire off some Node.js or some Ajax commands, right? And then what they do is they are asynchronously calling back to the server and getting additional information and pulling it into your web page. And that's when you see those little spinners. So like if you load a page, like if you go to Mashable.com, which is nothing but posts, as you're scrolling, you see them filling in. That's all Ajax. So Ajax is saying, when I'm visible, go get the data. And it makes a call, and it gets that post, and it pulls it in. So that's what's going on, and that's kind of like, so what I'm telling you is you have 1, 2, 3, 4, 5, 6, 7, 9, 10, all locations where there could actually be a caching variance in your cached data. But when done smoothly and well, no one notices that, and everything works well. And then there's just more specifically looking at all your caching opportunity locations, which I basically just discussed. So in a PHP function, you go and you get the most recent calendar, everything for summer 2017. Rather than going and getting it again and again and again, this PHP function, which might be, go get summer data, pulls it in and caches it inside the Drupal database as one big piece of string now, serialized data. So then later, when some page calls for that function again and wants the summer vacation information, instead of going to the database and pulling it again, it pulls it right out of the cache. So that's how you can cache it yourself as a developer. You control your caching. So then the APC cache, Redis and Memcache, MySQL query caching, Drupal 8's caching, which all turns into HTTP headers, which Varnish has to respect, and then Varnish can add headers of its own. It passes all that out to intermediary proxies, if there are any, and it finally gets to the browser. Okay, so caching results in PHP functions. This is what I was telling you. And in here, you're going to have some excellent examples, if you were to follow these links, of how to cache data in your functions. It's actually like really quick. You just go, someone makes a call to this function. Is it in the cache? No. Oh, then do it over. Cache it now. Next time someone calls, is it in the cache? Yes. Don't do it over. Just return it. So that's basically what goes on when you cache in functions. That's the alternative PHP cache. At some point in your career too, you're finally going to find out that something gets stuck in this cache. And you're changing it. And the customer is saying, I don't see it. It is plausible for this thing to get stale. It's plausible for it to get corrupted. And you have to clear it. And there's actually a function call in PHP that will blow out that cache for you. And every once in a while, you need it. So then this is object caching. So Redis is an open source project written in C. C is typically considered some of the fastest response language out there, much faster than PHP, and that's why libraries are usually written in C and other seriously performant product. So in order for your website to talk to Redis, in Drupal in particular, you're going to need a module, which is going to speak to a PHP intermediate library, which is going to speak to Redis. And that's the chain you need to use Redis in Drupal 8. Same thing with memcached. You're going to need a memcached module in Drupal 8 that speaks to a memcached library that speaks to memcached itself. So, and this information is just here for you to have it handy in case you want to take a quick look into what these products are and how they really work.
Do you have a preference?
I'm in a situation where I use Redis all the time, and I've been like that, let's say, for 5 years. And for some reason, memcached has kind of been just like sneezed away, let's say, and there's no serious dialogue at all of using memcached.
And what do you put in Redis? Do you do session, lock, the whole 9 yards, the cache?
Yeah, a lot. Now, there are particular cases in Drupal 8 and Drupal 7 where you can say, okay, Redis is going to be my cache and take it over from Drupal. And you put that in your settings PHP. You say, let Redis handle it. But there's actually like 6 or 8 different granular cache sections inside Drupal. So you could literally say at the beginning, send everything to Redis, and then have a one-liner that says, but send everything for forms into Drupal, and save it in Drupal nonetheless. So forms don't go out to Redis, and other granular things. So yeah, my impression is, in general, for top speed, the general consensus has been that Redis is just going to be faster. If configured correctly in an enterprise environment where Redis is on its own server by itself, it's going to be more performant. So MySQL query caching. So this is inside MySQL's memory. As soon as something changes in any table that has been touched in that query, MySQL invalidates it itself and will call that query fresh again if it has to. This is usually totally invisible to you, and you don't even need to know about it, but I just wanted to mention that that does occur. So Drupal 8 caching, we're going to get to that in detail as we go along. Okay, so the headers that you're typically going to have to deal with for caching. In general, there are response headers, which are the headers that are going out from your web server to the browser, and then there are the request headers, which are coming from the browser all the way back to the web server. So you're going to need to deal with cache control, expires, etag, vary, xvarnish, which is going to tell you that this page is being handled by Varnish Edge and Via. Special headers that come from Drupal. Drupal cache. This is telling you inside Drupal this page was cached from the performance settings page, and it was considered a hit, which means it was taken from a cached version of the page you requested inside Drupal. Not inside Varnish, not inside some other caching proxy in the middle, but from Drupal itself. Xgenerator, yeah, that's just, currently was Drupal 8. 2 special new cache tags in Drupal 8, which I believe have been backported to Drupal 7, and these are special for interfacing with CDNs like Fastly or Cloudflare. And what these allow you to do, and we're going to get to them, I'm going to show you them too, cache contexts and cache tags. These are special headers that are more granular and you can then literally say, if a page has been tagged with, say, News 7, you can send a page with an HTTP header on it into Varnish via the cache tags that says, invalidate only that single page called News 7. And Varnish will throw it out of its memory and make the next request come and do it again, and then it'll cache it again after that. So you cannot see these headers in Drupal until you turn them on. You have to go into a YAML file, add a setting, and then they'll get exposed. That's actually called Surrogate Keys, what I just explained to you. And so what I want to say is, if you actually want to work it out with Drupal, that you want to use Surrogate Keys, you're going to have to turn them on, and then you're going to have to do some work or install a module. Because let's say I mentioned Fastly and Cloudflare because they're pretty much the two CDNs that you'll hear the most about with Drupal 8. They respect surrogate keys based on tags and contexts. They just call them something else. So you're going to have to translate that, or like I said, install a module that will translate it for you. So there is a Fastly and there is a Cloudflare module that you can install in Drupal 8 that will make these surrogate keys headers for you correctly so that Fastly and Cloudflare can interface with you. And on these pages where the type is a little small, I'm assuming if you have time, you can read it later if you would like. So it was just as I explained, using those Drupal surrogate keys, cache context and cache tags, you can communicate to Fastly or Cloudflare, or say you set up your own Varnish box and you're doing your own home role caching, you can communicate with your own Varnish box to tell it to invalidate things at a page level. And where this becomes handy, and where I've seen it the most, is you have a blog, you have a government blog where people are blogging things today, like right now. And so the moment it's published, it needs to be available. There can't be any cached versions of it. If they make edits to it, that edited version needs to be instantly available and not like 5 hours later. So that is when you're going to use surrogate keys, and you're going to reach out into the Varnish cache, and you're going to say invalidate this single page only, and it's going to respect it for you. So blah, 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 blah. So at Fastly, it's called the surrogate key, and at Cloudflare, it's called the cache tag. So I'm showing you this information. You can read on it a little deeper in any of these links if you would like, or look into it. I can tell you, if you haven't lately looked at Drupal.org, and especially the Drupal 8 API pages, if you were to read the Drupal API pages from top to bottom, you're going to get so educated about Drupal, you will blow yourself off the charts. That's what I can tell you. No, and also, in the newest, you've seen that they've recently reformatted Drupal.org, and it's more like friendly and big and everything. They have an excellent section on Varnish, an excellent section on surrogate keys, excellent section on the caching API, and explaining how caching is handled inside D8. I just so highly recommend it to you. Okay, so Varnish, the idea is, I get all the requests that come to your website first, Varnish sitting in front of your website. And Varnish looks internally and says, has this page been asked for before? And do I have it in my cache? If so, just return it from here. Don't let it go into the back end. On the other hand, if I haven't seen it and it's not in my cache, I let it go through to the web server. The web server does all that processing, gives it back to me. I look at it and I say, hey, is this cacheable? It says yes, I cache it. Now I send out the response. That same request comes in again, I've got it here. I send it back, it doesn't go there. On the other hand, every cache has an expiration, every cache object. So it sits here, it gets the request, it looks at the object, it says, is this expired? No. Okay, use it. Gets the request, is this expired? Yes. Boom. Throw it out, go get it again. And then keep its expiration time as I've been directed in my HTTP headers. So this is nice and technical, but worth knowing. Varnish will only cache HTTP requests that are idempotent. Great word. I mean, I could not, I think I'm saying it correctly, idempotent. What it means is it is an action that does not change the state. So Varnish cannot handle things that change state, because that has to go back into the web server to change state and do dynamic things. Varnish doesn't do dynamic things. It either has something or it doesn't. So the only two idempotent requests are gets and heads. Every other kind, a put, a post, this is why a post will never get cached, because that's usually your form variables, and those should never be cached, or almost never. So that's why Varnish will not look at it. So Varnish can look at all these requests, but it does not cache them. Any other type of HTTP request that comes through Varnish, Varnish doesn't even look at it, it just passes it to the back end. But all the ones you see on this page, it can at least look at, and only gets and heads can actually be cached. So the Varnish cache can be configured in 3 different places, and I'm only telling this to you, sooner or later you're going to need to know that too. It comes with default settings that are built into the daemon, into the Varnish D daemon, without even looking at the startup options. The default cache expiration built into Varnish, even if you don't set anything, is 2 minutes, 120 seconds. So if you're ever sitting in a situation, you go, wow, they have no VCL file. There's no configuration, yet things are expiring after 2 minutes, that's built in. So if you don't change it, it's going to be 2 minutes. So, but then at startup time, you can pass parameters, which also set a whole bunch of options. What port do I listen on? What port do I send back to when I go to the web server? How long should things be for when they're expired? And a couple of other serious settings can be put in the startup options. But then there is the Varnish configuration file. So now this is the third location. That is where you can go in, just like a PHP ini file or an Apache HTTPD file. You go in there and you say what you want. But not only that, Varnish has a language called VCL, which you use inside the VCL file. And you can do things like say, oh, am I getting an image request? If I'm getting an image request and it hasn't been updated, or you could say, I'm getting an image request, don't even look back there. 7 days. I don't want you to look back for a new image unless it's at least 7 days old. And so this is another caching juncture which you could find yourself in. The user is saying, customer is saying, that asset does not change. Why not? Because the VCL file says don't change it for 7 days, no matter what anyone else does. So Varnish won't even allow the request for that item to go back to where it was changed. You have to invalidate it. So, or change your Varnish file, your VCL file to be more friendly. So that's just another juncture where you could have a little caching hiccup. So inside the VCL file, using the Varnish configuration language, so you can do that stuff. These are 2 very good articles that talk about it. This is an entry in a VCL file. And I'm pointing these out because this is also really linchpin. So Varnish talks to the back end, right? It gets a request, it's not in its memory, in its cache. It says, I'll send it to the back end. There's 3 different settings for Varnish when it communicates to the back end in terms of timing. So it says, how long should I wait just to try to connect to the web server in the back end? Then, how long should I wait to get the first byte of info after I have successfully connected? And then, how long should I wait between every byte in case there's a pause? And if it pauses too long, I kill the connection. So, any of these 3 things could go wrong. But at the front end, you might see 503, which just means couldn't communicate to the back end. But it's not clarifying to you which of these 3 could have occurred. So I'm pointing this out to you because you could be connected. But the application then, the Drupal site, could actually be so slow after the connection that it times out here. That's Drupal's fault. If it times out here, this is a network issue. This is the server is down or not connected. This is Drupal's fault. This is probably, again, a server issue. If it started to stream and then it breaks somewhere. So anyway, for you, if you can debug this granularly, you'll be able to tell, hey, this is a server issue. No, this is actually a website issue. There's some bad code that is looping or something. Just to mention, we're on Varnish 4.1. Varnish 5 is actually out. Practically nobody is using it. There are modules that you can add to Varnish that add a lot of functionality. Apparently, like everything. If you want to have certain settings and security levels and things, a lot of people have already done it for you. And you can just load a module, just like in Drupal, and add that to your VCL file via a module. Good to know. And Varnish Plus is a commercial service from Varnish where you pay for them to configure your Varnish the way you'd like. And they have all kinds of great ways to handle it. HTTP 2. Not technically caching, but worth talking about. So HTTP 1.1 is every request on the hypertext transfer protocol from the browser out there to get information, right? So today, the typical home page, let's say, makes 100 HTTP requests to 15 different hosts or websites and pulls down, on average, 1.15 megabytes of information. So that's why caching is important. You don't want it to have to make 100 requests every time on the home page if it's not changing. And you don't want it to reach out to 15 different websites. So that's why, so what HTTP 2 does, it opens one pipe from the browser out. And all those 100 requests actually take place inside this single connection from the browser. And what they've accomplished is this called multiplexing. They're saying that in this one pipe connection, we can make these 100 requests faster than 100 unique requests. So that's HTTP 2. That's what that is doing. So right now, as advertised, HTTP 2 could be twice as fast as HTTP 1.1. It could be 10 times as fast. But as usual, it's like, a car is rated for 50 miles to the gallon, but when you drive it, you get 35, or 41, but you don't really get 50. The chances that you're going to double your response time with HTTP 2 are small. And so there are other issues inside, like having one request, and there's complications also about caching these requests and everything like that. So, but that's just roughly to know what that is and how it could come up. And, because there are customers actually asking every day, can I get HTTP 2? All of these products already do it. Nginx, Apache, Node.js, Tomcat, Fastly, Cloudflare, Akamai. So if you want to use it, all of these services are already ready to help you. So, but there is some issue where your user could plausibly have a browser that doesn't handle HTTP 2. Very unlikely, but plausible. So that's something to know, and why it's not out there and everywhere today. Proxy and browser caching. So we talked about that. Another Varnish server somewhere in the middle there at your university or at some government or at some law office that you didn't know about that's caching your page and why your changes aren't taking place. So cookies and caching. If the response going out has a set cookie header in it, Varnish will do nothing to this page. It will never cache it. If the request coming in has a cookie in the headers on the way in, Varnish will do nothing to this page. Cookies are the language to Varnish that says this is always unique and can never be cached. So we come across this issue all the time where I work, where people are like, why don't my pages get cached? It's so slow. Well, because you use cookies on every single page for every single thing. So it actually becomes an issue as you get to the enterprise level of 100,000 hits a day, 1 million hits a day. Cookies and Varnish caching and how you actually cache pages and use cookies only so sparingly is an art form, and it's necessary to do. You cannot just turn on your website and go, we're going to put cookies for language on every page, we're going to put cookies for geolocation, and we're just going to make this a cookie-rich website. Your pages will never get cached, and your site is going to be slow. So you have to use cookies with a real powerful logic and you only set a cookie when you absolutely have to. Okay, basically inside Drupal 8, and I don't know if you remember, if you're going back to the first picture, I had this like little blue box, so that was Drupal, you know. So this is Drupal, this is that blue box expanded. So you can do caching in your code or in your custom modules or in your contrib modules, as I described earlier. Then comes your render arrays, which we're going to look at. And this is actually the most important caching concept in Drupal 8, and that's why I'm going to look at it with you. So then you have settings that come from Drupal 8's configuration. Views and panels have your own set of caching, outside and away from Drupal's caching. This sets all the headers. This goes to Varnish. Varnish does what it has to do. Okay, so I've discussed this with you, right? So caching and caching invalidation. So caching means save it. Caching invalidation means say it's old and I need to do it over again. So for Drupal 8, if you wanted to get a quick getting into learning about caching, this is all good stuff, all good to read. Okay, now let's get to render array. I'm going to come back to these. Let's look at a render array. In Drupal 8, you know, back in the old days, if you wrote a module in Drupal, right, and you wanted your output to come out at the end, you just wrote a function that said return display. And in there, you mixed HTML with your data and everything, and then you just outputted it. In Drupal 8, they would really prefer you never do that. That everything you output gets output into a render array, and every render array uses a twig template file. Now this is to finally provide that distinction between display and data. And so that the art people who do display can go into a twig file and play with it all they want and not mess up the logic. So this is a typical render array. It can have a prefix, which is something that's before all the stuff I'm really going to output. You can just output markup, which is basically some raw HTML, and this can be dynamic. You can have variables in it. A suffix is some HTML that gets output after my main stuff. This is the theme file that handles the logic that this render array is producing. Pre-render, a function to run on all the data going into this render array before it goes into this render array. And attached, when you need to attach specific JavaScript or CSS that is meant to be on a page only with this HTML, you attach it here. And when attached correctly like this, like you see here, Drupal will be doing all this logic on all your page loads, and it will no longer load. Like it used to be, if you loaded JS on one page, Drupal loaded it on every page and made a massive thing. Now it won't do that anymore. It will actually break your JS, your aggregated JS, and your aggregated CSS into multiple files that have been sort of, made streamlined, so that if this page only needs jQuery itself and one more JS file, which you attached here, it's only going to put those two on this page. So, and that's when you do it correctly using attached. And Drupal settings, this is where you can pass variables into the JavaScript that you might want to use. That's done with Drupal settings. So now let's look at cache. Context keys, tags, and max age. So the reason why render arrays are so important is because you have this quick access to cache settings. You can set the cache using Drupal 8 cache API functions. You can do that too, but that's a little more complex. Or you can just do it here using the properties of the render array. And so let's look at them real quick. Cache contexts. Cache contexts, let's go back. Cache contexts are these things. All of these things are a context in Drupal. That means that render array has to be re-rendered if the context changes. And the possible contexts that can change are cookies, something in the headers, the user's IP, the language, the route that it was on, a session, a theme that was in use, something that was in the URL, or something about the user. All those things, if they are present here in the cache tag, means if this block is on a page that varies by user, this block has to be re-rendered and it cannot be cached because it's changed by user. Or if there's something in the URL query, that's what this one is specifically saying. If you find a certain item in the URL, that will also mean uncache this thing and re-render it. Tags. This is really good, and this is where the big world of Drupal 8 like really works out. You have a web page over here. It keeps a list of the top 20 looked at articles, right? And maybe even the top 5 authors' main articles. So somebody goes in and changes a title. The author changes the title of his top article. And then in here, 2 of the blog posts that are top 20 get their titles changed. And say these are being presented also with their summaries. Someone goes in and changes the summaries or says we don't want to present summaries on this page anymore. Or we used to present 50 words of summary, now we only want 5 words of summary. If this whole page has been cached in Varnish, all those subtle internal changes aren't going to cause this page to update. Because this page was already cached as a monolithic block. And it doesn't know about those fine little changes. So that's where cache tags come in. This cache tag says that if this block is on a page, but anywhere in Drupal, node 42 changes, this block has to be invalidated, and any page it is on has to get invalidated, and it has to be rebuilt. That's what tags do. So tags are saying, I'm paying attention to the entire Drupal ecosystem. And if I say, the other tag is saying is if anything in the system configuration under performance changes, this block has to be re-rendered. I mean, that's just a crazy example. So that's what cache tags do. So this block can change by things in the context or by tags that we specifically said it depends on. Keys are what am I called that if some other render array says I want to change when this render array changes. And so it is known, this render array is known by these keys to those other render arrays. But like I said, this is really worth knowing, and I can tell you, however much of this information you walk out of here with, you are already in an advanced state. When you see it in writing, if you hear it come up in a conversation, you're going to be at least know it's caching, right? So, okay, max age means, okay, so notwithstanding all these fine details, if it's older than 300 seconds, invalidate it anyway and do it over. So max age is like the hammer, where all these guys are little fine-tuned little things. And so if max age is set to some specific time, regardless of all those other things, it will get uncached after that specific time. That is why you want to use render arrays, and that's why they're so important. So caching by context, caching by max age. 0 means it's not cacheable. 300 means in 300 seconds or every 5 minutes, change this no matter what. Okay, so it's advised in Drupal 8 that all of your output be done as render arrays so you can have that fine-tuned caching capability. So another thing that's going to happen, your cache tags and your cache contexts are going to get fed into those special Drupal 8 headers that I showed you way at the beginning. And then that's the vehicle by which, if this node changes, which changes this block, which sends this cache tag into the headers, which goes out to Fastly or to Varnish and says, cancel me and do me over. It all starts here. So this is your fine-tuned argument all the way out to the Varnish server to say if this block changes, invalidate everything where this block is on. And that'll all get done for you automatically. Drupal is keeping track of everything as it makes the page for you. So you may need to read more on that, and it's worth it. So block caching is done in your render arrays. Okay, there are some modules, that there's a caching list, on Drupal.org that has like 50 modules related to caching and what they do. That's worth looking at if you want to see. Popular ones are Purge or Redis, Memcache stores, Cloudflare. So what these all do, is what I was explaining, and in particular in Drupal 7, if you needed to invalidate a single blog post really fast, how did you do it? The purge module could do that for you. It had the ability to be configured to respond to node changes and then send an invalidation signal, the correct one, out to Varnish to knock something out of the cache for you. BigPipe. BigPipe is a lot like Ajax. So what happens is Drupal says, oh, on average, every page is 80% the same. So I cache that entire 80% inside the database. And then only these 3 blocks that change get sent dynamically later after the user already has this 80% framework in their browser. These come piped in, the BigPipe, into new blocks. The user has the finished page. That's BigPipe. So BigPipe originally was an experimental contrib module. It got included in core in 8.1. It needs to be enabled. BigPipe uses JavaScript on the client side, exactly like Ajax, like I explained to you earlier. And there's a lot of little explanations on it. Also, your server environment has to be able to support certain qualities that BigPipe needs. So if you think you're going to use BigPipe, you need to enable it. You got to take it for granted the client's going to have JavaScript, and your server needs some settings that are going to work with it. So these 2 modules are turned on by default in Drupal 8. The dynamic page cache and the page cache. BigPipe is not turned on. So caches pages for any user, handling their dynamic content correctly. Caches pages for anonymous users. So this is Drupal's internal page cache. And this is before it gets sent to Varnish, which is caching things separately for you. This, in theory, speeds up Drupal's internal processing so it doesn't have to keep doing stuff over and over again. It is separate and different from the Varnish cache as being done with HTTP headers. Just good to know. We're almost done. Drupal 8's performance setting page has like two things. Turn on some gross caching number for the website, 5 minutes, 10 minutes, 1 minute, and aggregate JS and CSS. That's all that's there today on those pages. Explicit bubbling of your caching. So Drupal looks at every page, and whatever the tiniest element is, if this single footer block says, invalidate me every 3 minutes, but everything else on this page has some other criteria, the most finest one wins out, and Drupal will set the final cache according to the finest setting. So as I indicated, CDNs, Ajax, Edge side includes. A good thing about cron. Cron will often invalidate your cache in bulk. So it's good to know that cron can be blowing out your cache, and that could be a reason why things that you thought should stay cached are getting uncached. Well, system cron could run and just say, clear the cache, clear Drupal cache. So modules like Elysia cron and Ultimate cron allow you to control every single task that's inside cron and time them exactly and put them in order. It's fantastic. I highly recommend, if you're not using Elysia cron yet on your website, you should. The Drupal 8 API is your best reference, and that's it. And if you haven't looked at any of these pages, if you want to learn more Drupal, these are excellent resources. And every presentation that's ever been made at a DrupalCon is actually on YouTube for you to watch for free on the Drupal Association channel. Okay, well, great. Thank you very much. Sure.
I got a question.
Go ahead.
I was looking over BigPipe.
Yes.
I love that concept. I think that's really cool. I was also researching as maybe as a possibility to use it in place of instead of BigPipe for doing partial page caching.
Yeah.
Using Varnish VCL, it seems like it's possible to tell VCL to have do the same thing BigPipe would be doing.